say patients with diabetic foot ulcers, patients who we know have a problem with chronic wound healing. And so there is a animal model for that. They take mice that are genetically deficient in the hormone leptin, and these mice, so-called OB mice, because they become obese. They weigh, 2 to 3 times a control mouse weight, but they also become hyperglycemic, and they have documented delayed wound healing. So we said, well, what happens if we, paint some of this stuff on a wound? So when you take the mouse, you cut a 2-centimeter patch of skin out of their back, and then you wait to see how long it takes for that skin wound to heal. So we did that experiment, and this is what we saw. This is the measured wound size, obviously on the y-axis, and this is time in weeks on the x-axis. So the regular diabetic mouse takes about 4 to 5 weeks to heal. And when we painted on a single application of the high-dose bar combination, you see that it accelerated wound healing by about a week or so. Now that doesn't look quite as dramatic as the effect we saw with the hernias, but turns out, as I was informed, in the plastic surgery and or wound healing literature, there is actually nothing that's ever been determined to do any better than that, meaning improvements of about 20% are about as good as you ever see, whether you're using growth factors, hormones, or what have you. So that was actually, for him, pretty dramatic finding. Do you have a question? No. So, don't know how it works. And in fact, unlike is our tradition as kind of clinician scientists, when you have an interesting observation, you then spend your time focused on mechanism. That actually is irrelevant when attempting to commercialize a product. You're much more concerned about toxicity, cost, efficacy. Maybe you'll figure out how it works, maybe you won't. Now, it may sound odd, but I'm not so sure that we know how general anesthetics work in general. We've been using them since Martin showed us in the movies. So, I think that there's obviously something about the fibrin matrix that is formed, and this is another example of, I consider, serendipity. That is the choice of fibrin. Fibrin glue, which is just basically thrombin and fibrinogen. So when thinking about this idea about putting these silver microparticles in a wound to try and promote scarring, my immediate concern was, well, you want to make sure those particles don't kind of filter their way into the abdominal cavity or go somewhere else. So I said we want to figure out something that would sequester them right there at the wound. So I knew, since we have available to us in the operating room fibrin glue, that would be one thing that'd be cheap. So I contacted Baxter, who's the major manufacturer in the United States, and said, can you just give me some fibrin glue for cheap, for free. So it's like not my garage, but it's close. And the local sales rep said no problem. Her regional manager said no problem. But then there was a problem. The national research advisor, whoever, something, wrote me and said, or called me and said that they need me to fill out this form. And the form was basically a disclosure of what you're going to be using the product for. I wasn't going to do that. So I just said no. I said, that's all right, I'll figure out some other way, and decided I'd have to either buy it or something. But the local sales rep was absolutely appalled that here this very lucrative account of theirs at UCSF was being denied this product. So she then informed me that she could actually just kind of come by every once in a while, and she does. And now I'm like swimming in this stuff. But these choice of the fibrin probably was critical, because we've subsequently gone back and done experiments where if you put the silver in alone, it actually doesn't work. If you put other metals, we've tried gold, because gold sits right below silver in the periodic table, so we try to pick something kind of similar. doesn't work. I'll show you some of that data in a second. But the fibrin matrix alone works to a degree, as you may have recognized or remembered from the initial slide. And I then came to realize that, or my hypothesis is that the fibrin really is the initial matrix that's formed when you're attempting to heal a wound as a result of trauma. And so it may be actually the perfect matrix to try and create this improved wound healing environment that does prevent incisional hernias. It's not that important. So this is some of the data I was just mentioning to you. So this is now hernia rate in the rats. If you just treat them with saline. If you use fibrin glue alone, that's just the tissue matrix, you can reduce that hernia rate from here is 90%, and you get more animals, that gets down to about 40 or 45%. If you use gold, it doesn't tend to work. Works a little bit, maybe you get higher doses, but actually gold has some toxicity associated with it. But it doesn't work clearly as well as the silver does. So, this is obviously the process that we're attempting to manipulate. And so now that I have this separate arm, or separate, I've divided the project into the commercialization phase versus actually trying to understand what's going on. And our initial focus is on macrophages and trying to determine whether or not ionized silver has any influence on macrophage either activity or phenotypic differentiation as kind of the initial straightforward hypotheses. So we formed a company about a year ago, February 2012. Formed a small company. The university has filed a patent around this product. It's very interesting. The university, as I said, they own it, so it's really their technology. They do acknowledge me as the inventor, but the actual filing of the patent, they don't pay for. They actually don't pay for anything. Because of the kind of renewed or increased interest within the university around innovation and commercialization, there are a variety of alliances that have been formed, and one of them is with a very well-known intellectual property law firm here in San Francisco, Fenwick West, and they completed what was called a freedom to operate analysis. So, over the years I was thinking about this project, I would try and identify in my own mind what were the clear-cut reasons this wouldn't work, because you don't want to waste your time, right? You want to kind of think through it. And one of the things that was always concerning to me was, this is such a simple idea, is it even patentable? Can you, because silver's been around forever. It turns out that most of the patent law regarding silver is when silver is either in its elemental form, as part of some compound, or as a nanoparticle. And we specifically chose not to use nanoparticles because nanoparticles actually are small enough to be engulfed by a phagocyte and have actually been shown to induce apoptosis through DNA damage. So we actually that became a critical issue for patenting. But then I learned about this whole concept of freedom to operate. Does anybody know what that means? So let's say, for example, you come up with the idea for a rocking chair. And you say, you search, and no one has ever designed or patented a rocking chair. So you go ahead and file your patent, and you'd be granted that patent. The problem is you would not be able to, you could make the chairs, but you couldn't sell them. Because your patent would overlap with the patent for the person who had developed the chair. And your rocking chair would be viewed as a variation or an extension of that patent. So you'd have an infringement that you'd have to then negotiate some licensing agreement. So you would not have freedom to operate or freedom to execute your patent even though it was unique. So it was important for us to not only determine that this idea was patentable, but that in fact there were no other patents out there that would block this, that we would need to exercise a license over it.
Did you have to pay for that?
Yeah, no. Well, Yes. So the way it works is the law firm was willing to commit $25,000 worth of services essentially on spec, meaning that they're not going to charge me, but that when the company is funded, then they get paid, and they have the opportunity to buy a piece of the company. So, you know, it helps you. The more successful you are, you know, the more you'll pay for it. But then, you know, that's kind of the way most things are. They're otherwise free. So we're now looking to do some toxicity analysis on our product. Because, you know, silver has been a part of medicine, or it's been used for several millennia. The Phoenicians understood that you could store wine and water in silver containers, and it would preserve it for a much longer period of time than putting it in clay or some other ceramic vessel. There's not really much in the form of solid organ toxicity from silver. Now, there are people who suffer from a condition called argyria, and here's one of them. So here's a guy in his youthful, probably like in the 20s or 30s, and here he is in his 50s and 60s, and he looks like, you know, Papa Smurf there. This is argyria. It is a kind of discoloration or tattooing of the skin resulting from the incorporation of silver in dermal or skin-associated macrophages, which then the silver being exposed to UV radiation actually gets reduced, and its absorption changes, and then you end up with this coloration. But he was somebody who was engaged in a process of consuming so-called colloidal silver. So there are people, if you get on the internet, you'll find them, who believe that silver has a variety of magical properties. And so they run currents through silver wire placed in water or some solution, so you can actually get a certain amount of dissolved, you know, certain, you know, 10 to 50 parts per million of silver in solution. Then they drink it. And then they, you know, they drink it a lot, and they drink it over many, many years. You too can look like Smurf. But he has no organ injury. Kidneys work fine, liver's fine, no brain damage. You know, it's not like a lot of metal toxicity you'll see with mercury or lead or gold. So, but we're going to have to prove to people that, you know, that putting the silver in somebody's wound isn't going to kill them. We've got to figure out how we're going to actually, you know, deliver it. And then we've got to do a clinical study. We've got to prove that it works in patients, because right now we're just, you know, rats are signed, you know, with relief that I can now prevent them during their surgeries. That's not a very lucrative commercial market. So we have thought that we'd like to look at a very high-risk group of patients, because then we can look at a much smaller number and still show a sizable effect. So we have decided to look at liver transplant patients. So here, almost looking like a Kaplan-Meier for survival, but instead it's a Kaplan-Meier equation of curves for the development of an incisional hernia. So you're 100% hernia-free at the top, and you're 100% of patients have hernias down at the bottom. And then this is time, and that's in months. So this is out to 10 years. So, you know, here's a group of patients who are followed regularly for basically their entire life, right, a liver transplant patient. And what you see is that depending upon what type of immunosuppression the patient has received, their risk of an incisional hernia varies. So patients who have received a calcineurin inhibitor like cyclosporin are here, which means that they have about a 30 to 35% chance of a hernia somewhere between 3 and 4 years. Certainly within the first 2 years, they're up around 20 to 25%. That's a high-risk group. If those liver transplant patients instead are treated with an mTOR inhibitor, something like rapamycin, this is the mammalian target of rapamycin, that hernia rate is much higher. You can see at 2 years it's probably around 50%. So we're now starting to negotiate doing a trial in this particular patient population. This is also a group of patients where their physicians, their surgeons are well aware of the problems with incisional hernias because they see it so much more frequently, and they follow their patients. Most of the patients I operate on as a general surgeon, I never see again, once their problem is gone. And most patients actually do not link their incisional hernia with a problem with their surgery, because it occurred a year or two later, and invariably they'll think, oh, I must have lifted something too heavy, or I went back to work too soon, or whatever. They're blaming something else. This is not. So this is just. So if you start doing the math, say, okay, well, if you're going to attract someone to invest, you've got to prove to them that they can actually make a boatload of money, or no one's interested. Another somewhat depressing but just reality of life, problems that affect small groups or vulnerable populations are very, very difficult, if not impossible, to get anyone interested. Though they'll all say to you that, of course, they find meaning in their investments through the fact they're helping people. That's clearly not the case, I don't think. This is a huge potential market. If you just look at all the people in the United States, or in North America and Europe alone, who undergo surgery, who would qualify for prophylaxis, it's somewhere in the neighborhood of $3.5 billion market value per year. If you talk about patients who are having other types of hernias repaired, which would be kind of the natural off-label indication that people would use to say, well, to prevent a hernia may help me decrease that 40 to 50% recurrence rate when I fix a hernia. It's just, estimated easily over $5 billion a year. And that tends to get people's attention a little bit. But at the end of the day, we're going to need, obviously, data that's convincing from patients. And that's the only reason that I'd be interested, obviously, in pursuing it, is if it were to work. That's about it. Last thing I'll tell you. So, our company, you may or may not have noticed, is called Vitruvian Medical Devices. So, you've all seen this drawing of Leonardo da Vinci's. It's actually called the Vitruvian Man. And it is, so Leonardo da Vinci would write, and he would write, so I'm told, in a mirror. So I think he was actually left-handed. Anyway, it's basically illegible when you just look at it. But I'm told, for people who have somehow translated this, that this writing above and below this drawing is really kind of an ode to Vitruvius, who was sometimes referred to as the father of modern architecture. And Vitruvius, one of his kind of main principles was that architecture should be strong, functional, but beautiful, and are aesthetically pleasing. And Leonardo da Vinci here is basically saying, just like the human body, there's obvious symmetries to the human body and certain beauty. So when thinking about the company, I said, well, when looking at this diagram, as a abdominal wall surgeon, that's the center of the drawing, right? Is the abdominal wall. So that was, kind of a compelling reason to use this as a logo. But the clincher was the fact that art historians, just in the last, I think within the last decade, have determined, or at least are speculating, that the Vitruvian Man may have a hernia. And when you look at the drawing, this little bulge in the drawing, they think is actually a hernia in this model. So that is kind of a divine sign. So I don't know if any of this has been of any value to you, but I'd be happy to take any questions or.
And we didn't even get to your filmmaking.
No,
yeah,
no.
That's another.
That's another day.
I was wondering how you met with in regards to the patenting of this, how you dealt with requiring fibrin glue that's from the outside.
Right. So the patent on fibrin glue has long expired. And you can even debate that you can't patent a naturally occurring product. That's being debated now. I think the ruling now is that you can't patent genes and so forth. So most of the patents around fibrin glue are the process by which you formulate, whether right now, Baxter, for example, runs a series of blood donation centers, and they take pooled human plasma. They obviously isolate and try and obviously filter the viral contaminants, but so they can be patenting around all of that. But there's no need to worry about the use of fibrinogen per se. Fibrin. Yeah.
Often, when I've seen patents being developed they'll extend not only the patent to their particular product, but also whatever iteration they could possibly think of, like using gold particles. Did you include other things in your
Right.
patent?
So that's a great question. With my total lack of knowledge in the field, I had read through a variety of patents, because Google patent, you can look up anything. And I was convinced that there were so many other patents that would exclude this that it wasn't going to be patentable. And so I had made this list of about 10 patents that I thought were really going to be blocking patents and taking them to the patent attorney. So when they gave me this analysis, it took them about probably didn't take them 6 weeks, but 6 weeks later I sit down with them. This is kind of like, I don't know if you've ever been on the other end of the phone and somebody's going to give you your HIV results at a needle stick or something. It's like you're like thinking, okay, the answer to this question could really be a deflection point in my life. That's what I was feeling when this guy sitting around about to tell me, is this patentable? Everything that I had read was so irrelevant that it wasn't even on his list of things to focus on. So it turns out that you can include in a patent all kinds of things, but in the absence of data, it doesn't mean that patent will actually be defensible. And it turns out in the world of patents, so I'm told, that a patent is only as good as its challenge. Meaning, it's when somebody challenges your patent and you actually end up in a court of law in front of a judge or your peers, and they determine whether or not your patent has or has not been violated. That's the only time you ultimately know how strong your patent is. Otherwise, it's a series of opinions, but the prevailing opinion is, in the absence of data, kind of listing every possible permutation is probably not going to be defended.
So how did you get the mindless seal to begin with? Did you partner with industry to develop the silver or the you bought?
Right. So, it's the joy of the internet, Mike. You can find everything on the internet. One of the things I have found most enjoyable about this process is the education, kind of the re-education, the learning something really, really new and different. And I see this as an extension of my efforts to solve, what is a medically important problem. That's what I do every day, right? What you'll be doing. To answer your question specifically, so if you look online, you can find a number of vendors, but there's one in particular that it's called American Elements, and they just sell virtually any element you can imagine in just like silver alone. There must be 50 different ways you can buy it in terms of size, shape, issues of purity. So that was easy, turned out. So we just buy it, online. Just sent to us.
It's like Breaking Bad.
Well, good. Well, good luck to all of you.
Thank you.